Hey, so the other day we introduced runes, which are going to be the new way to deal with state in Svelte 5 and beyond. The reaction has been remarkable. Million plus views on the tweet, top of Hacker News, takes everywhere. Overall, very positive reception. So, thank you for putting your faith in us. Even outside the Svelte community, people seemed pretty excited. Every framework community was tripping over themselves to be like, hey, this looks like our thing. They say that imitation is the sincerest form of flattery, but I actually think the most sincere form of flattery is accusing someone of copying you. I guess I should set the record straight on that front. We essentially designed this stuff from first principles, based on everything that we've learned since Svelte 3 came out in 2019. But the intellectual context in which we did so was very much influenced by the work of Ryan Carniaro on the Solid team. So everyone else, I'm afraid we weren't really thinking about you, but I'm glad you like it anyway. That said, there were some naysayers, and the bulk of the negative reaction that we saw was basically, I don't want to have to write getters and setters everywhere. This is way more code for basic things. Even the great Fireship, who I have boundless respect for, got this totally wrong. And that's our fault, because we didn't do a good enough job of explaining it. So in this short video, I want to explain what getters and setters are, why we're using them, and why it's not going to result in you writing a bunch more code. So first up, what are getters and setters? Well, imagine that I'm creating a create counter function in regular JavaScript. I type create counter up here, I declare a count value, I add an increment function, and then I return count and increment directly down here. And then I call the function to get a counter instance. I log counter.count and I get 0. Great. Now I increment the counter like that and log the count again. It's still 0. What happened? Well, you can see what's happened. The count is fixed at the time we call the function. We're just returning an object that has a count property whose value is 0. And the way that we fix that is with a get property. So I'm just going to copy this code. And this time we're going to do get count. And then we're going to return count like that. Right, and then if I do counter equals create counter, counter.count, 0, obviously, counter.increment, and then counter.count again, we now get 1, which is what we want. Now we could also have a corresponding set property, which would mean that anyone who had a reference to this counter would be able to set the value of counter.count to whatever they wanted. But that's not what we want in this case. We only want people to be able to increment this value. You'll notice also that we can't destructure the value. We can't do const count increment equals counter. We can, but now if we call increment like that, then it's not going to do anything useful. We're always going to get the same value because the get method is invoked at the time of destructuring. Now, if this syntax is new to you, then this might all seem a little bit weird, a little bit funky, but you actually use this stuff every day as a web developer, whether you realize it or not, because web APIs are full of this sort of thing. So here's an example. If I log out location.href, I get example.com. If I set location.hash equals hello, then, oops, syntax error. Then you'll notice that the URL bar is actually updated here because we're not just setting a property, we've invoked a setter function. And then if I log location.href again, you'll see that that new hash is part of the string that gets returned because we didn't just get access a property, we invoked a getter function. So this is all just JavaScript. This is just how the language works, and it'd be pretty weird, honestly, if it worked any differently. So what happens when we throw runes into the mix? Well, the only difference between this and what we had before is that we have this state rune in our declaration. And what this means is that Svelte now understands that wherever this value is read, for example, inside this expression right here, that thing will need to update if the count value ever changes, for example, because someone clicked this button and ran this function. That's all. That's the only difference. And so at this point, you might be thinking, okay, I understand that, but why getters? Why isn't it just a normal method? And it totally could be like we could do this instead. Just a normal method, and then we invoke it inside the template, and it will continue to work. You can do that. It's your choice. The reason that we prefer getters is threefold. First, and maybe the least important point, it's idiomatic, right? Property access is how we read and write values in JavaScript. There's a reason that we don't have location.gethref and location.setHash, for example. It's just not idiomatic. Secondly is because of TypeScript. And this is a little easier to show rather than describe, so I have a little demo here. So here we have a function that returns an object with a pair of methods, get and set. And the thing inside it, this type argument, this t value, could be anything. So down here I have user, which is a wrapper of user or null. Like we don't know which one it is. And now down here we have some code that runs when there is a user value. When we call user.get, there is a value, means the user's logged in or whatever. And so inside that we can do some console.logging. But TypeScript thinks that this value here could be null because that's what this function returns, because that's the value of the type argument. And so we get this red squiggly here, and we have to fix it by, we could make a non-null assertion, or we could have a temporary variable like const u equals user.get, and then inside there, if u, and then the same thing inside there, like all of a sudden it works, but like ain't nobody got time for that. Another approach that we could do is we could use the getter and the setter, like here. So now we have get value and set value, and down here TypeScript understands that if user.value, which here could be user or null, inside that if block, we know that it can only be a user. And that's something called type narrowing. And when you have a function call between you and the value that you're trying to access, TypeScript starts to get a little bit confused. Unless you're using getters and setters, because it understands that those are idempotent. Finally, in Svelte, we have bindings, right? If we look at our fine-grained to-do example, which you can find in the docs over here, then we have these bindings inside the template, which if I toggle these, you can see that remaining count changes. And the reason that we can do this, and then we don't have to have all of this laborious event handling code, like I need to remember what the event is, like blah, 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 blah. The reason we can do that is because we have this symmetry between reads and writes. But, okay, so the main thing people were worried about was I don't want to write all of this shit all over my code base. And you're not going to have to for two reasons. The first is that you only need that stuff when state needs to cross a scope boundary. And what I mean by that is within the scope where a piece of state was declared, you can interact with it directly, right? You only need to provide a getter or a method or whatever when you need to read the value outside that scope, as in our counter example. Most of the time, when you're dealing with state, you're doing so locally. Either it's component state or a prop, which also doesn't need this treatment, or you're writing some complex business logic where most of the state references are internal, and you just need to expose the end result of some process. So even though we've been focusing on this case in the blog post and the video and all of that stuff, in order to show how the new stuff works, it's really the exception rather than the rule. And the second reason is that we're going to develop patterns for dealing with this stuff. Right, so let's take Fireship's example where we have a piece of state that we want to interact with outside the scope of this module. So here's that implemented here. Right, we're exposing a writable store as a count, and then inside our app, we're interacting with that store and reading the store value. So in Vue, we might use something called a ref. And a ref looks a little bit like this. All right, let value equals state initial. And then we'll return get value, return, excuse my inability to type under pressure, and then the corresponding setter. Right, and then we, instead of using the writable function, we'll just use ref, and then inside here we'll change these to count.value. Right, and it just works exactly the same way as it did before. So you can imagine that this is imported from a utility module or somewhere. Maybe it's even exported from Svelte itself, TBD. So you're not having to re-implement that every time you want to have some piece of state that is shared between different components. If you prefer Solid's approach to Vue's approach, they have a create signal function, which looks like this. And again, we're just going to create a reactive piece of state. And then this time we're going to return a pair of functions, one for reading the value and one for writing the value. Right, and then we could do export const get count set count equals create signal 0, like so. And then inside here, we could do get count set count. And then this would become get count. And then inside the event handler, we want to do set count like this, right? And it works just the same way. So we can implement all of these different reactivity patterns using the primitives, right? And candidly, we just don't know yet what is going to end up feeling most natural. So for now, we're just giving you these primitives in a very raw form. And we've already seen people produce some really interesting abstractions on top of them for doing, things like deeply nested reactive objects. By the time Svelte 5 ships, we'll hopefully have a clearer picture of this stuff. So we'll know what we're going to include in the framework to make dealing with this stuff feel very natural and very lightweight. All right, so I hope that clears things up a bit. Keep the feedback coming. It is super helpful.